And I think now I see Dino on the full screen. Let me change this. Okay, okay. Let me share my screen. Play from current slide. This should be super quick. Just set up some context. And probably before we even start, I just wanted to say that initially we said, like, let's have 30 people or at least 25. We had this little requirements before we actually start looking for a speaker from outside, right? But luckily, over like 2 weeks, we were able to gather 160 people. And even for this event, we have like 120 people who actually subscribe, which is pretty amazing. So this is, I hope everybody's able to join, because usually with all those clicks, links, sometimes it's difficult. Maybe we get a bunch of the messages, hey, I cannot connect, what is the password, and things like this. We'll see. Now, let me cover this super complex slide. Why? Right? Because the only reason why we want to actually set up this group is that there are so many teams in SAP that are working with Angular we don't even know about. So that's why we wanted to create one true cross team, or you could actually say cross LOB collaborations page, where we can actually share and have opportunities to share some common skill set, some experience, and so on, so on. And maybe they are team who has problem and we already solve it, right? Or they are team who needs help and we need to get each other. So that's why we are here. And the plan is every month, probably depending on the topics and number of availability of those speakers, we want to actually bring always one external speaker from outside. Even today is kind of exception because this is the first meetup. And always to bring one internal speakers, and these internal speakers can be me, it can be you, it can be anybody. Anybody can probably step out and start actually sharing some important topic to bring certain value, because we're trying to actually create something different, something that actually attracts Angular community within SAP more than we have it now, right? Who we are. And I think this slide should be more who we are not. We are not, and we should not be one-man show. Even right now, this is run by 2 different companies. And together with Kevin and Dino, my name is Frank, we prepared this presentation for you, but this list should not end here. That's why I have this little question mark, because if you want to help us, we would just welcome. And if you have some content, please share, right? And another who we are is that I need to actually mention SAP Ariba, which can actually help us to organize all of this and give us actually the space and time to prepare this meeting, plus fundamentals. I have all these meetings, hold on. And fundamentals family, who among other things has one project which is called Fundamentals in GX, which is fully featured component library, which is based on Theory 3. And as you know, Fundamentals is powered by Fundamental Styles, which is direct implementation of Theory 3 design guidelines. And of course, last piece I need to mention is SAP open source. And as you know, SAP open source is SAP group who actually runs all the open source activities. And among other things, they also have talks. They have different meetups. They have podcasts. You should definitely look them up on the GEMS pages. Okay, this is pretty much what I wanted to cover. And I don't really want this delay more than it is necessary. And let me welcome Minko and Manfred, who is going to share some pretty interesting topic. And in terms of organization or logistic, So we will have Minko right now, then we will have probably 5-10 minutes break, depending how you feel, and they will just run directly to Manfred, and we will leave Q&As to the end, because for some of you might be getting late, so I don't want to actually delay this too much, and we'll probably start right away. Other point is that I will probably mute you, all of you, and if you have any questions, what I would recommend, let's start using chat window and let's start aggregating all those questions to the end, and then we can probably start read them one by one and always write to whom this question is and what is the questions. This way we will not actually lose anything. And let me run a little test, which I actually ran on last my meeting, because it's super important. When you want to have something to say, or when you want to raise your hand, or you have some important topic to say, or maybe you want to just point out something, please raise your hand. And to raise your hand, there is a little smiley icon called reactions at the bottom in the toolbar. And if you click this, then next to your name, we will see that somebody raised a hand, or you can actually clap when we actually welcome somebody, right? So let's run a little test. Let's raise hands, everybody right now, right? At least we know that we understand how this Zoom works. Pretty nice. Cool, cool, cool. Okay, it works, pretty nice. Lower your hands, and we can get started. Let me stop sharing, and Minko, it's yours.
Okay. So I assume you see my screen and you hear me.
Yes.
All right. So thank you very much for joining, and thank you very much for having me. Today, I'm going to present a not too technical talk. It's going to be mostly about the state of Angular, where Angular is organizationally inside of Google, what we have been up to lately, and where the Angular is heading. So from there, my guess is that Manfred is going to take it on with a more technical topic, probably about microfrontends, but I don't want to spoil his surprise. So yeah, let us get started. Over the past, so Angular we have been working actively on Angular for over the past about 5 years now. And always for us, among our core values have been to build a framework that allows developers to build applications that their users love to use. Also to develop the framework in a way that it provides the development experience so that developers love to use it. And because we're developing Angular in the open, and we have a large community of over 1.5 million developers, we want to make sure that everyone feels welcome in the process. And it's very interesting that these core values are often, sometimes even competing with each other. What provides great development experience doesn't necessarily always makes user happy, and what makes users happy doesn't always provide great development experience. So it is very interesting to balance between these two. When we start talking about the features that we shipped recently, we're going to talk more about these competing priorities as well. So yeah, when talking to developers, generally some of the strengths that they're manifesting for Angular are its opinionation, its scalability, evergreenness, and ecosystem. Today, I want to focus particularly on the evergreenness and discuss how Google organizationally inside supports us to make Angular an evergreen framework that allows to keep up to date with the latest improvements and standards just by using the Angular CLI. I joined Google about 2.4 years ago, I believe. But before that, I was contributing to Angular for over 7 years before I joined the company. So I have been part of the community for a while. Something that I noticed when I joined the company was that everything was changing very rapidly. And SAP is a large enterprise as well, so I'm pretty sure you're familiar with the concept. But at certain points, the reorganizations in the company were happening so fast that I had these chocolate candies as celebration of one of the reorgs, which this chocolate candies I still had in my fridge, I wasn't able to eat by the time the organization no longer existed. So we were like constantly restructured in order to ensure higher efficiency and to make sure that we're serving the actual users of the framework. Angular has been building infrastructures since the very beginning, even since the very early days of AngularJS. But we were originally positioned under ads, and we were building infrastructure for the products that we were supporting. Over time, however, we started getting higher adoption within Google and also the external world. So it made sense to move to a little bit more functional structure, and in particular, to core systems. Currently, Angular is in core system, which builds the core developer, which builds the infrastructure for pretty much most of Google right now. And in particular, we're under core web. So together with the TypeScript team, the build and serve team, and our sibling framework team called Wiz, we have been building the web infrastructure for the entire company. Something which, based on my experience, has been unique to Google is that our team, our Angular team, is supposed to support all the projects that are depending on our framework. I'll say that this is unique, probably mostly because of the monorepository that most of our code exists in. So just to give you an idea how many projects we would have to support and how much fun we're having with this, when Angular got released in 2016, clearly nobody was using Angular in the framework. I was on the release event in Mountain View, and I was really excited to be there. I wasn't working on Angular full-time back then. I was part of the community, but the version 2 release was kind of a big deal. There was this party with the balloons, and Jules, Brat, Igor, and Mishko, they were hanging out on stage, exciting us about what is going to be the future. And that was 4 years ago. Currently, we have over 2.6K projects that are using the framework inside of Google. And these vary from very small dashboards or shopping cart lists even to things like Google Cloud, which has over 1.5 million lines of TypeScript Angular code. And our responsibility is to maintain all of these projects. On top of that, there are hundreds of thousands of TypeScript files, literally. I think that I looked them up, there were 500,000 TypeScript files. Clearly, not all of them are Angular. The majority of these projects are using Angular, since we were the project which introduced the TypeScript language in the company anyway. So it's interesting, how do we manage to make sure that all these projects are keeping up to date with the latest changes in the framework, and how we're making sure that we're not breaking them with even a patch release. That's thanks to the monorepo though. I don't know if you're familiar generally with this concepts. I wasn't that familiar within Google. Although I was using some monorepos, they were with just a couple of projects within them. They weren't with all the source code in the company, just pushed into a single directory with subdirectories that communicate with each other. Generally, the small repo structure helps us with stability. You can imagine that we have pretty massive code coverage, test coverage. There are hundreds of thousands of test targets that are constantly being retriggered every time when we change the framework. So if we break something, an API that we don't even know that existed, well, we're going to break a test target. We're going to break an end-to-end test or a screenshot test, and we're going to figure out that we have broken the framework. So this way it is pretty easy for us to understand when we are doing framework changes that are impacting not only Google projects, but also the external world. This helps us also with automation in different senses. For example, with automation, when we want to innovate, we want to be stable, but at the same time, we want to break stuff. And in order to keep up with the latest web standards, or in order to come up with more ergonomic APIs, or deprecate existing APIs that are just not widely adopted. We want to roll out automation across all these projects. And we can reuse this automation scripts later on in the external world as well. It helps us with innovation because we have access to all this project source code. We can see how they're using Angular, and we can get new ideas on what framework improvements we can ship. But I would say probably the biggest user-facing implication of the structure is that we have the ng update command. Another user-facing implication, I guess, is that it took us 3 years to ship Ivy, but that was for the good thing because we made sure that Ivy is mostly backwards compatible with some very small exceptions that we knew how to automatically migrate by rolling out large migrations. I mentioned that often we have competing stakeholder requirements in Angular, right? Sometimes what makes an Angular developer happy doesn't necessarily improve the web experience for the consumers of the web. And it's very interesting to manage an open source project because we have quite a few interested parties. Only the language service has close to 1.8 million installs, and we're getting a lot of feedback in different forms. Probably the most prominent form is the number of GitHub issues that we used to have. We're doing better there. Also, a lot of customer requests, customer feature requests from meetups like the one here, or from other on-site events when the world was not as closed. We're running annual surveys. For example, only as part of our annual survey in 2020, we got 30,000 responses. So we had to analyze them and figure out what are the next steps and how we can improve Angular further. Clearly, there is certain technical depth. With the release of Ivy, we are going to get rid of Vue Engine, which is our previous rendering engine. And this is something that we need to prioritize, and so on and so forth. So generally, when we have to prioritize any of this work, we're looking into the core values and thinking whether this is going to improve Angular for the end users, whether this is going to allow us to provide more accessible and faster experience for the web, whether we can do that in a way that developers are going to have a good development experience, and finally, whether we're going to be able to ship it in an inclusive way so that most of the folks from the community who are interested in helping out, they can be involved in the decision-making process. Usually when we find such intersection, we're moving forward with the prioritization or development with any of the feature requests that we have discovered during using different sources. One of the, when I was like looking back at the slides, I thought that probably the release of Ivy was one of the few good things that happened in 2020. And at the same time, it feels like so far away. Version 9 was the release of Ivy, and this was pretty much the entire like framework rewrite by keeping the same public API, which took us about 3 years to complete. And that was necessary for us to move Angular forward, to reduce the complexity specifically, improve the performance, specifically load time performance, and enable better development experience APIs for more granular, let's say, lazy loading, to making Angular zoneless, or removing and making ng modules optional. These are all things that we're going to discuss just in a little bit. But that was a necessary change, which took us a while. And in the meantime, we collected quite a lot of technical debt. We had at a certain point over 2,600 issues, although the majority of them were just feature requests, which we just intentionally decided to keep open. We still had to do like a lot of work in making sure that we are getting rid of legacy code and supporting the community in terms of bug fixes and performance improvements. So that was the focus for our last two major releases, just making sure that we're going through this backlog. We're introducing scalable processes for automation in order to ensure that we're reducing the noise on GitHub, and we are also able to respond as quickly as possible to feature requests and move forward with the evolution of the web. For example, we have been collaborating actively with Chrome on a couple of features on how Angular can deliver better metrics for the core Web Vital user central metrics that are going to be eventually part of the search ranking system as well. So in terms of triaging issues, we were able to go through all of them. About 100% of the issues across our 3 monorepos are now closed, or not closed, but triaged. They're labeled and for future consideration or associated with a particular component. And now we're in the process of rolling out a feature request process, following an example from VS Code, where they're in a pretty similar situation with a large community with a lot of feature requests. They want to be able to prioritize the features, not only by popularity, but also by alignment with their future vision. So in the next couple of weeks, we'll be in the process of rolling out a new process for automatically handling feature requests by allowing people to vote for them. And when certain feature request gets a given amount of votes, we'll be able to consider it for prioritization as part of our backlog. In the meantime, we're able to resolve some of the very highly wanted issues. For example, improvement of the lazy loaded modules in named outlets in Angular. We're able to ship an improvement with using translations in component files, a couple of improvements in forms, other improvements in router, and so on and so forth. Generally, our focus has been to improve the responsiveness in some of the long-standing issues that folks have been really asking for. But together with this legacy work, we were able to also ship some new improvements, some new features. Highly demanded improvement was just having faster and more responsive internationalization pipeline. I don't know if you're aware, but in Angular, we're shipping out of the box an improvement for a feature for internationalization of applications. In our internationalization feature, we're taking a slightly different approach compared to most other technologies, where rather than loading the translations dynamically at runtime, we're using our compiler to statically analyze your templates, figure out where exactly you're using translation strings, and from there, producing different outputs of your application with statically embedded strings for the different internationalization targets that you're supporting. This pipeline now, it works in an entirely different way, where we're producing these individual builds with almost zero cost once you have compiled your application. And we are supporting also loading these translations, even at runtime, if this is necessary, a constraint for you. But particularly for our internationalization pipeline, we have been entirely focused on performance to ensure 3 shakeable translations and also 0 runtime overhead coming from data binding. This is one of the improvements that was probably the most effortful right after the version 9 release. And if you have a use case for it, I'll definitely recommend you to take a look at this blog post by Pete from our team, who explains everything in more details. Something that I've never heard from anyone, literally, is that their builds are fast enough. So at certain point, even though we have incremental build pipeline, it is hard to go much faster from there. Like, there are certain tricks that you can do. For example, use very aggressive caching. You can share this cache across different team members by using remote caching with tools like Bezo or currently even NX. But at a certain point, though, when you're using your cold build or starting your development server, there is a certain amount of work that your build system needs to do in order to figure out what is the dependency graph, put it in the memory, and from there on, compile the individual assets to their form that is consumable by the browser. In order to, and there are other tricks as well. For example, not having to compile the entire application, compiling only the smallest portions out of it, depending on the changes and how they propagate in the build graph. And from there, only pushing these small changes to the browser through a WebSocket and monkey patching the entire application on demand. So this is something that has been available in a while with hot module replacement, with HMR in the JavaScript ecosystem. But we didn't really have a great solution for it. I mean, it was working. You were able to use HMR with Angular, but the experience was really painful. So as part of, I believe, version 10 now, we were able to ship our, actually it was version 11, excuse me. We're able to ship our hot module replacement API that now comes in by default with the ng-serve experience when you specify the HMR flag. Together with the improvements in the compiler and the build pipeline, we're working on a new way to distribute Ivy libraries. So Ivy is this new rendering engine that I mentioned a while ago. And the way that we are currently recommending you to distribute your libraries is by reusing the previous format that the compiler used to output, called view engine. However, this was adding some extra build time, especially in your post-install scripts, because we had to compile the previous version, like compile your view engine libraries to Ivy with our compatibility compiler. So as part of version 11.1, we shipped a preview version of our Ivy library distribution that is going to help with this even further. And starting from version 12 and further from there, and starting from version 12, pretty much we'll start encouraging people shipping their libraries in Ivy format, which is going to speed up the post-install phase, since this compatibility compilation would no longer be required. Another major effort that has been on our radar for, I'd say, at least a couple of quarters has been improving the debugging experience and error messages for Angular developers. So we did a lot of work there in terms of making sure that the source maps of the generated code by Ivy for your templates are going to the correct locations in Chrome Devtools. So when you click on a stack trace, rather than going to the cryptic generated code by the Angular compiler, you're going exactly in the right location in your template where a particular error happened. We also worked on improving the error messages for stuff such as expression changed after it has been checked, which is probably one of the most prominent errors that the Angular runtime has been throwing. But another effort was to just ensure that all the error messages have some extra context associated with it. So we went through all the different errors that Angular could be throwing. We prioritized all the errors, and we developed guides and videos for the top candidates, which are now live on Google, on Angular.io. When you get any of these errors and you follow the URL, you'll be redirected to Angular.io, where you can get further context on how you can debug and potentially fix any of the issues. This is an experience that you're probably familiar with even from AngularJS. The next step here would be to just introduce this in production and add individual placeholders that would make your error message guides even more context aware, and we'll be showing symbols specific to your application rather than having a generic guide on how you can debug the error message. The focus on performance has been pretty high as well. So I mentioned our collaboration with Google Chrome. We have been working on them on ensuring that Angular stays up to date with the latest standards and with the latest performance trends. So as part of the Chrome Web SDK team, we worked on a couple of optimizations that are helping primarily for first contentful paint and largest contentful paint improvements. We work primarily on inlining of different assets, starting from CSS and going to fonts. So currently, when you're building an Angular application, we're going to statically detect the critical CSS in it. We're going to inline it, and we're going to load the rest of the CSS dynamically without blocking the initial loading experience for your users. We noticed that in certain cases, this brings over 3.7 seconds of improvement for largest contentful paint, mostly because there is no this blocking nature anymore. Once you start loading your application, it doesn't have to suspend the rendering of the content until it downloads the files, because the minimum amount of CSS that is critical for your app is already part of the HTML file itself, and everything else is lazily loaded, which is applicable for screens that you're going to navigate to in the future. So this has been one of the major improvements that we're going to enable also by default in version 12, because we noticed that quite a few companies are already benefiting out of it, specifically for client-side rendered, server-side rendered applications, and applications using pre-caching and app shell. A few other improvements as part of version 11 are Webpack version 5 preview. We released our Ivy language service that you can actually download and use today, and trusted type support. Trusted types is this new standard coming from the Google security team, which aims to introduce a new mechanism for handling XSS directly in the browser. So this is very similar to the different sanitizers that we're pushing with Angular and that you're able to use in order to bind to unsafe content, but it is coming by default as part of the web platform. And clearly, there are also quite a few bug fixes and improvements. The coolest thing is that if you're not on version 11 just yet, if you're in version 9 or so, we have been working hard to make Angular evergreen. So you should be able to take advantage of this improvement just by running ng updates with the Angular CLI. So let me spend now 2-3 minutes talking about what's coming up next. And after that, I'm going to pass it to Manfred. Generally, we have been focused on improving the development experience and the build time, as I already mentioned. With Webpack version 5, we have been working hard to make sure that the incremental builds there are enabled by default in V12. So this is an improvement that will be coming and is currently planned for V12. There are still a couple of breakages around our Webpack V5 support, specifically in the way Webpack 5 manages web workers, but we're on our way of resolving that. Manfred is going to be talking more about how Webpack 5 supports Microfrontends, and we have been also working on Angular Devtools, which is another portion of the debugging and error messages experience that we have been cooking over the past couple of quarters. I'll talk about Devtools in a second. We have been looking into how to reduce the conceptual overhead for Angular and make ng modules optional, and also how to make zones optional as well by allowing you to have more fine-grained control over your change detection. Devtools is probably going to be one of the major things that we're going to release in the near future. And this is an experience which provides very similar functionality to what Augury currently does, but rather than having only the elements and components explorer in your browser, where you'll be able to navigate through your application structure and explore your component state, you'd also be able to profile your app and figure out how much time you're spending in your individual components and in change detection, what triggered particular change detection cycle, and eventually in the future, it will give you hints and tips on how you can speed up your application by using, for example, a different change detection strategy or focusing on decomposing your components to smaller pieces. I don't know if you love zones, for example. Pretty much I do not. Mishko in Angular Connect 2019, excuse me, 2020 happened, like nothing happened this year. Mishko in 2019 talked about how we're making Angular fast by taking advantage of different optimizations of the JavaScript virtual machine, such as inline caching, let's say. And Angular is like pretty fast by itself, however. However, we notice that often zones trigger change detection much more frequently than they have to, which adds up some extra CPU cycles on top of your execution and generally makes your application experience sometimes even a little bit laggy, blocking the main UI thread. An optimization that we have been looking in this space is allowing you to have finer grain control over change detection, where you'll be able to invoke it in particular places only when it is required with our zoneless API that we have been designing. This is a change that is probably going to land in the next, let's say, a year or two. I don't want to set any particular timelines because there are quite a few variables here, but this is another large project that we have been looking at. And at the same time, clearly, we want to do that in a way that everyone feels welcome and our goals and priorities are clear. That is why you'll see all these updates on the Angular roadmap, which is available on angular.io/guide/roadmap. And also for the major efforts, we will be running community RFCs. In a similar way, we already did for our library distribution and elimination of render blocking resources. Yeah, that was pretty much most of it, what I wanted to share with you. I want to share how interesting it is to juggle between these competing priorities, which are impacting both the user and the development experience, and how also interesting it is to do it in a such open, inclusive way where we're able to brainstorm not only within the boundaries of our team, but also the broader Angular community as well. Thank you. Yeah, thank you very much for having me. And that was all I had for you today.
Thank you so much, Minko. And if anybody has any questions, we have this chat window and you can actually shoot those questions, which we'll try to sort out at the end. And how everybody feels. Do you think you can actually go on with the Microfrontend, the revolution in Microfrontend world, or you want to have 5 minutes break? I mean,
I would say let's continue.
Okay, you feel confident? Okay, very good. So I guess I will not block Manfred. I will just
maybe one
Manfred.
question to Minko.
Yeah,
from my side, if you have some time before jumping to Manfred.
Yeah, go ahead.
I mean, if he's fine.
Yeah, absolutely.
Yeah. So you mentioned that this kind of reworks in your side, and still maintaining all these thousands of projects at the same time, and all the practices that you guys doing. So when you migrate breaking changes in Angular, so basically you're able to test in other applications at the same time, right?
Mm-hmm.
Through this monorepo.
Yeah, we have global CI, and every change we do, we sync inside of Google.
How much time does it take when you trigger such a change to get all this result? Is it fast, or it takes some time, or
Yeah, so we have different kind of checks. The more complete check takes probably over 20 hours, but we also have a subset of selected projects that we can trigger on demand. So if you look at on GitHub, actually, one of the checks in our repository is called G3. That's how we call our repository, like Google 3. Probably there was Google 1 and Google 2 before that, I guess. When we see that something fails in Google 3, we are just more careful with merging a particular pull request, because it looks like there is a breaking change potentially.
And one thing that at least I appreciate, and I think most of the community, you were able to, convince that breaking changes isn't always a bad thing, right? Breaking changes always brings also some kind of innovation and, forward, right? It doesn't have to be painless forever, and then you don't get anything out of it. So if you have to do breaking change, how do you maintain in this thousands of projects? Do you do it, or the other teams that, I mean, obviously they have to do some change, they have to do manually? I mean, obviously there is also automation, but how is this streamlined if you have to do a breaking change?
Yeah, we are migrating the projects. If we break them, we have to fix them. So it's on us. And for example, if you remember the migration from RxJS 5 to 6, that was a pretty major change where everything was very dynamic at first, and we ended up in RxJS, and we ended up changing it to this pipe operators where we were able to chain them after one another. This was a large script which migrated all these thousands, hundreds of thousands of files using RxJS to the new version. And this script by itself, it took over a quarter just to make sure that we were able to collect the correct type information, that we were able to migrate all the use cases. But the cool thing was that we did that, but also everyone else in the community benefited from it. With the case of RxJS, not necessarily only Angular developers, but anyone out there.
I mean, thanks. This is a valuable information for us since, you know, SAP it's a big company and, you know, how we can reflect on our side this part. Thanks.
Yeah, I've heard that many companies are using, for example, schematics, update schematics to achieve something similar. Yeah, okay. I'll stop here.
Yes.
Thank you.
Thank you, Minko. Manfred, it's yours.
Okay, so thanks for having me. And also thanks to Minko for this great presentation. So Minko already mentioned it, that Webpack 5 is enabling module federation and microfrontends. And now I want to dive a bit more into this topic. But first of all, I want to start with a picture. Perhaps you already know this picture. This is the helicopter that has been designed by Leonardo da Vinci. In 1400 something, he designed a helicopter. He only designed it because he didn't have the material for building it. But nowadays we have the material, and scientists found out it would really fly. How cool is that? And somehow the story reminds me to the story of microfrontends, because the idea is everything but new. We are using microfrontends for decades. We are using stuff like iframes or other workarounds to make it work. But so far, we didn't have the right material to build it in a very straightforward way. And this is now changing with Webpack 5 and Module Federation. Before I tell you about Webpack 5 and Module Federation, let me tell you what I mean when I'm referring to microfrontends. Well, first and foremost, I mean several tinier frontends that are for one specific business domains, and those frontends need to be integrated into a bigger application. From a developer's perspective, we have a lot of tiny, less complex applications. From a user's perspective, we want to have one big integrated solution. And that's why we need to find a way to load all those micro frontends into something like a shell. Here you see an example for this. Here I have a micro frontend. It has been developed by one team. It has been deployed by them at some location. And here we have the shell that is loading this very micro frontend or also other micro frontends on demand. As mentioned before, in the past, we needed a lot of workarounds for doing something like this. But now we can leverage module federation, which has been shipped with Webpack 5. And this is what this talk is about. In this talk, I will tell you first and foremost about module federation. And then we will talk about federated Angular. That means I will show you how to use those ideas together with Angular and the Angular CLI. And at the end, I will show you when you can use all of this safely for production. Currently, some of those things are experimental, but in the near future, it will be production ready. Let me also introduce myself a bit. I am Manfred. I'm a trainer and consultant for Angular. My focus is on Angular for enterprise scale applications. I'm helping a lot of companies with workshops and also with consultancy. Besides this, I'm quite connected to the Angular community. Perhaps you hear it by listening at my accent. I come from Austria. I'm also doing a lot of stuff in Germany, and I'm always happy if I can work together with other companies around the world. In days like this, it's quite easy because currently everything takes place remotely, isn't it? Okay, let's get started with the first chapter I've prepared. This is about module federation in general. Module federation, at the end of the day, is answering this very question here, namely how to load separately compiled code. Code that has been separately developed by a specific team, code that has been separately deployed by them. And perhaps you say now, well, come on, Manfred, that cannot be that difficult because we have dynamic imports, and even before we had something like require. So why not use those statements to point to a chunk out there in the web, and why not use it to load it into our application? Well, the thing is, in theory, this works perfectly. In theory. In practice, this does not work at all with current bundling solutions like Webpack, because those bundling solutions assume that everything is there at compile time. Everything needs to be known at compile time. Everything is compiled together. Everything is optimized together. Think on tree shaking, for instance. And then, and only then, it is cut into chunks for lazy loading. But this is too late for our purpose, because we don't want to know everything upfront. We just want to know all those micro frontends at runtime in order to load them into our shell. And that's why the Webpack team introduced module federation. Module federation solves this issue by introducing two roles. The first role is officially called the host. For me, it's the micro frontend shell. The second role is officially called the remote. For me, it's the micro frontend itself. And you can configure both using the Webpack configuration. For instance, you can define mapped URLs for your shell. You can say, hey, this URL mfe1 points over there to another micro frontend. And well, by the way, over there, it's also called mfe1. You could also define an alias here. I went here with a non-alias because I'm mapping mfe1 to mfe1. Over there, within the micro frontend, you can expose files. You can say, hey, let's expose this Angular component or this Angular module, or even this file with a function. You expose it and you assign a pretty name to it. Everything you are exposing can be directly loaded by the shell or also by other micro frontends. And now something beautiful happens. I guarantee you, you will love it. Now you can use a dynamic import to point over there, to load something that has been exposed over there. Just use the map names. And this is really beautiful because this shows that Angular itself does not know at all that we are talking about micro frontends. It does not know at all that we are loading something that has been separately compiled and separately deployed. That means we are using Angular as always. We don't need any special things in Angular, just use it as it was intended to be used. And underneath the covers, Webpack is doing the heavy lifting by loading stuff from over there. This also means that we don't need any meter framework. Meter frameworks for orchestrating different applications with loaded into our shell. Of course, the shell needs some metadata about the micro frontend, something like the URL or even dependencies the micro frontend needs to use. And for this metadata, the micro frontend provides a so-called remote entry point. This remote entry point is generated by Webpack when you build the micro frontend. And then you should load it into the shell. It's best to load it up front into the shell. The sooner you load it, the better it is. It only has about 3Ks in production mode, so it's not a big deal. But if you load it up front, the shell knows how to deal with this micro frontend and what needs to be loaded to make this micro frontend work. For instance, it could find out that it needs Angular core in a specific version to work. Also, when we are speaking about sharing libraries, you can define that you want to share a common bunch of libraries. If you are using Angular, it's likely that you need Angular Core, Angular Common, and other stuff in each and every micro frontend. But obviously, you don't want to load Angular 10 times just because you have 10 micro frontends. You just want to load it once. And that's why you can tell Module Federation to share Angular Core, to just load it once and to share it across all the loaded micro frontends. Okay, that sounds quite amazing if you ask me, but one question that comes in mind when looking at this is, how does this work together with Angular and especially the Angular CLI? And when it comes to this, I have a good message for you. The good message is the Angular CLI is already using Webpack underneath the covers. It is already leveraging Webpack to compile applications. This is the good message. The bad message is that the CLI is shielding Webpack from us. Well, honestly, most of the times this is a good message because we don't want to get in touch directly with Webpack. We've tried this before, it wasn't that funny, huge Webpack configuration. So it's a good thing that normally the CLI shields it from us, that normally the CLI is just using it to do what we need. But now we need somehow to communicate with Webpack directly, because now we have a module federation config. And this configuration needs to be squeezed in somehow. And for this, you can leverage a custom builder. Perhaps you know it, the CLI is quite flexible. It is not directly using Webpack, it is using Webpack over a builder. A builder is just an exchangeable strategy for building applications and libraries, also for linting them or for testing them. The default builder for Angular application is using Webpack, but we could now create a custom builder which is delegating our module federation config to Webpack underneath the covers. And after that, it could delegate to the default builder so that this builder is doing what it is always doing, namely triggering Webpack to build an application. Of course, you could write such a builder by hand, but you don't have to because I already did it for you. You can download it under this name. It's called Angular Architects Module Federation. And basically, it does three things for you. It generates the skeleton for your module federation config. That means you don't need to learn it by heart. You just need to fill in placeholders. This is the first thing. The second thing is it installs a custom builder that is enabling module federation underneath the covers. And the third thing is it assigns a new board to your application so that you can serve them side by side in order to try them out using Microfrontends. The usage of it is quite straightforward, if you ask me. You just need to ng-edit, then you need to adjust the generated configuration, and then you can ng-serve it and be happy because hopefully it works. So much about the theory. Now I would say, let's have a look at the demonstration for this. I think especially here, this is quite important because I'm always saying module federation and microfrontends is a lot like the 1980s. You need to experience them to know what they are about. That's why let's have a look to this. So here in my example I've prepared, I have two applications. The first application is a shell. The second application is a microfrontend. And when I'm clicking here to flights in my shell, then we see that nothing happens because implementing this route is now my job. At the end of this presentation, I want to be capable of loading this microfrontend into this very route here. And saying this, both of them shall be deployable in separation. To prove it, I'm going with localhost 5000 here. Let's zoom in a bit, and with localhost 3000 there. Of course, this is not a prerequisite. Having different boards, having different origins is not a prerequisite. But here I'm doing it to prove that everything can be separately deployed. Let's have a look at the source code. So if we look into the source code of this, we see a monorepo. We see a monorepo with my two projects. Here I have Microfrontend 1, and here I have a shell. And also here, having a monorepo is not a prerequisite. You can also have several repositories. It does not matter for module federation. If we look in my package.json, we see that I'm using the CLI 11. Last week, I have tried it out successfully with the current beta version of CLI 12. But there is a bad message for you, namely, when going with CLI 11, we get Webpack 4 by default. The thing is, we need Webpack 5 because Webpack 5 ships with module federation, and this is currently not officially supported by CLI 11. And this for a good reason, because CLI 11 and Webpack 5 came out at about the same time, give or take 3 or 4 weeks. And so there was not enough time to adopt it to Webpack 5. But as Minko told you before, this is the goal for CLI 12, which is due around May, give or take a month, I would say, if I look into my crystal field. The good message here is, even though CLI 11 is not officially supporting Webpack 5, there is an experimental opt-in. We can say, hey, I am taking the risk, please use Webpack 5. And for this, you need this section here, this resolution section, which is telling Jan that it shall force everyone into Webpack 5. Regardless which Webpack version they are requesting, they are getting Webpack 5. This only works with Jan out of the box. There are some packages for NPM, but if you are seeking an out-of-the-box solution, then go with Jan. As mentioned before, Webpack, CLI 12 will support Webpack 5. That means you don't need this workaround with CLI 12, which is due in May, plus minus, give or take. Okay, I have already installed my dependencies using Jan. And now let's install the CLI extension. Let's ng-add Angular architects module federation. We are just ng-adding it. Of course, now it's downloaded. And when it's downloaded, it asks us two questions. Namely, which project do you want to enable for module federation? In my case, it's obviously the shell here. And the second question is, which board do you want to use for testing? Which will be board 5000 in the case of my shell. Okay, so it's about the shell, and let's go with board 5000. And now we see a lot of stuff is generated. For instance, a Webpack configuration is generated for us. We just need to fill in placeholders in there. Or within the Angular JSON, my custom builder is registered. The custom builder that is enabling module federation. Let's do the same for the Microfrontend 1. For Microfrontend 1, I have a second tab here. Let's close it. ng-add. Yeah, the project name is MFE1, Microfrontend 1, and I want to go with board 3000. Here it is, the same stuff is generated. Now let's have a look into the source code of this. Let's start with Microfrontend 1. If we dig into the source here, we see that this is more or less a traditional Angular application. There's nothing special in here, nothing but this Webpack config that has been generated before. This is where we can configure module federation. As you see here, it's not a big file. It only has 2 screen pages when I'm using my big font sizes here. And the most important stuff is located in here within the module federation plugin. Here we have two sections. The first section is for remotes, or as I would call it, for microfrontends. The second section is for hosts, or as I would call it, for the shell. And here, of course, we are talking about the microfrontend one. That means we go with the first section and we get rid of the second one. Here I'm assigning a unique name to my microfrontend, and I'm assigning a name for the remote entry file. You remember, the remote entry file is the file containing all the metadata. The metadata the shell needs to be capable of loading this microfrontend. Also, I can expose files. I can say, hey, I want to share this or that file with all the shells out there. In my case, I want to share something under the official name module, and it is my flights module, flights.module. If we look into my flights module, it's nothing special in here. It is just a traditional Angular module with child roots. The nice thing is, because I'm using child roots here, we can directly activate those child roots within the shell. Because we can use the router for lazy loading, using module federation to load this package here, to load this module, and then the router can directly jump into this or that child roots. Besides this, here I'm also defining how I want to share which libraries. You can configure how libraries shall be shared and how to behave if there is a version conflict. Here I'm saying, hey, let's load Angular core, common, and the router just once. It's a single, it's loaded just once. And if there are two non-compatible versions, then I will get a runtime exception because of strict version. This is just one strategy you can configure. There are several strategies to deal with version mismatches at runtime. Yeah, and that's it. So at the end of the day, my microfrontend, one more time, is just a traditional Angular application with this configuration file. Now let's have a look into the shell. Let's close MFE1. Let's have a look into the shell. And here we see also our generated Webpack config. It's more or less the same. Now we can get rid of the first block, which is for microfrontends, and we can go with the second block, which is about the shell. I'm mapping MFE1 to MFE1, and here I can also hard code if I want the location of the remote entry points provided by the microfrontend. This is where the shell gets all the metadata from. Of course, hard coding is not the fine English way of doing things. I'm also calling this static federation, and it is first and foremost for testing, debugging, prototyping, and so on. If you intend to do something for production, I would go with an alternative. I will show it to you in some minutes, which is called dynamic federation. Dynamic federation allows us to define all those information at runtime. That means with dynamic federation, the shell could ask the backend, hey, backend, which microfrontends can you offer? And then the backend can say, well, we have this and that microfrontend, and then the shell can configure module federation at runtime with this data. But to keep things simple for the beginning, let me start with static federation. Besides this, I'm also sharing Angular core, Angular common, and the router. So far, also the shell is a traditional Angular application plus this Webpack config. Now let's introduce a route for the shell, a route that routes over to the microfrontend. I have already prepared it here. This is a traditional lazy route. It is using load children. It is using a dynamic import. And the dynamic import is pointing over to the micro frontend by using the mapped paths. MFA1 on the one side, module on the other side. And as mentioned before, Angular does not even recognize that we are loading something from over there. For Angular, this is just lazy loading. For Angular, this is lazy loading, but Webpack knows underneath the covers what to do at runtime to resolve this file. That means it's fine for Angular, it's fine for Webpack. It is not fine for TypeScript. You see it here, TypeScript is complaining. It is saying, it is saying, hey, I don't know this file, so this cannot work. And now we need to ease TypeScript a bit. We have to tell TypeScript, come on, TypeScript, trust me, I'm an expert. This will work at runtime. For this, we need a DTS file. The name doesn't matter, just call it DTS so that TypeScript picks it up. And here we could define that this will work, that a file like this, or to be more precise, a module, a TypeScript module like this exists at runtime. And now it's also fine for TypeScript. It trusts us that this will work at runtime. Okay, that's it more or less. So at the end of the day, just traditional Angular applications with some configuration stuff. Now let's start everything. Let's start the shell. Let's start the micro frontend. We will see some warnings here because, as mentioned before, the Webpack 5 integration is an experimental opt-in, but you know, warnings are for hazards. And hopefully after this has been started, so here was the warning, red letters, but it's indeed a warning. And after everything has been started, we can hopefully load the micro frontend into our shell. So let's try it out. Let's reload it. Let's click here and hey, it works. Let's have a look at the network tab. Let's reload everything. Let's click here and where is it? Perhaps I should retry it. Let's reload everything. Oh, I have some special filter, I guess. Give me all, yeah. Flights, and here it is. Yeah, the name is not perfect. It's called CommonJS, but it's indeed our micro frontend. It has been loaded from over there. You see it here, localhost 3000, where the shell is, one more time, located at localhost 5000, and it's
I think, Manfred, did we lose you or is it frozen?
I think we
Looks
lost him.
like.
Did we hit the limit of Zoom?
No, I think
actually
it's could be network problem.
It's normal. It's normal. Okay, we cannot hear you. You are muted.
okay, cool. Have I been away for a long time or just for some seconds?
10 seconds.
Okay, that's good.
10
For some
seconds.
reason, it started over again. Yeah. So, as mentioned before, so far we just saw how to go with static federation, but now let's leverage dynamic federation. We want to tell our shell at runtime which micro frontends we have. So let's comment this out. Let's move over to our app roots. And here, let's say goodbye to our import. Let's replace this import with another helper function, which is called load remote module. It's one of two tiny helper functions provided by the Module Federation plugin. It is directly talking to Webpack. There is a Webpack runtime API. It is located in your window object if you compile something with Webpack. And yeah, it is communicating with it and telling it, hey, now we know about this or that microfrontend. So what is the remote entry here? Well, let me copy paste it. It was this string. What is the name of the remote? It was MFE1. And what is the exposed module called? It's just called module. Of course, like a dynamic import, this helper function is just loading the whole TypeScript module. We need to project it to the Angular module in question. And that's it. So now you see we are defining all this metadata that points to our metadata at runtime. Of course, here it's also hard-coded, but you can imagine that we can grab this information, that information from the backend, from some self-made registry service, and that we can feed it into those routes here. This can be a string containing everything. Okay, let's try it out. So for this, we need to reload at least the shell. And let's also restart the microfrontend. One more time, this takes some seconds. While this is starting up, I can tell you about a little tiny drawback of this approach. One drawback here is that we are also loading the remote entry point, the metadata, lazily. But when it comes to preventing version conflicts, it would be nice if we loaded this remote entry point upfront. And this is also doable. For this, we have another helper function. Okay, so the shell is loaded. Hopefully, so is the microfrontend. Let's click here and yay, it works. So let's retry it. Here we have our network tab. Let's click flight. And now you see both is lazy loaded, the remote entry and the microfrontend. And this is okay, but in a perfect world, you would load the remote entry upfront when the application is starting. For this, there is also a helper function within this package. If you look up the README, you can find out how to do it. The thing is, as mentioned before, if we know the metadata upfront, we can more easily prevent version conflicts. Then we find out, hey, Microfrontend 1 is using Angular 11, Microfrontend 2 is using 11.2. 11.2 is backwards compatible to 11, so let's just load Angular 11.2. Those are very smart things our federation can do if we have the metadata upfront. Okay, so much for the demonstration. Perhaps you love this. Perhaps you say, well, finally we can scale our teams. Finally, each team can work on a tiny micro frontend. They can work in isolation and they can also deploy when they are done. When can I use it for production? Well, the thing is, Webpack 5 and so Module Federation is final. Go with it. However, CLI 11 only provides experimental support for Webpack 5. But CLI 12 will hopefully officially support Webpack 5. Minko told us about before, and it is due in, I would say, May, give or take a month. And yeah, then we can go into production with all of this. So it's not far away. You can start prototyping today, and then you can go into production when it's done in 1 or 2 months. So if you like this talk, you will perhaps also like my free ebook. I have updated it, heavily updated it for module federation. Now it contains about 5 chapters about module federation and microfrontends. And you can download it here on my blog, angulararchitects.io/book. And if you didn't like this talk, well, perhaps I'm writing better than I'm speaking, who knows? Give it a try. Okay, let me come to a conclusion. We have seen that module federation is the new kid on the block because it allows us to separately or to load separately deployed code. This is also the key for micro frontends, and by the way, it's also the key for plugin solutions, where you have a, let's call it, software as a service product, where customers can load several extensions into it. Also, it can be used together with Angular. In this case, I'm calling it federated Angular. And there is one last thing I really want you to remember. If you forget everything, please always remember this one last thing, namely, this is now the perfect time to become the next Leonardo da Vinci. So take your chance. You can not only do your great designs, now you also have the right material for building your dreams. Take your chance. So thanks for having me. Here you have my contact data. You find all my examples and slides on my blog. And if you like, follow me on Twitter so that we can keep a bit in contact. Thanks for this.
Thank you, Manfred.
Thank you so much. Great. So right now, I will just open up a space for Q&A. Unfortunately, Minko had to left for his Google meeting, so maybe he wanted to avoid some of the questions, who knows, but at least we have Manfred here, so we can actually start massaging him with some of the questions that you guys have, right? So if you have questions, since we have only one speaker now, we can actually freely raise your hand so you can actually start asking him. I have a few questions on my side, but I will let others ask if they have something. So I'll shut up now.
Hi, this is Abhijit here. Manfred, I just have a small question regarding module federation. In the scenarios where we are having, let's say, an upgraded solution, a hybrid application with, let's say, a higher version of Angular and a legacy version of Angular JS 1.x, will module federation also work in such a scenario?
Yeah. So if you ask me, using module federation and also using micro frontends is quite a nice strategy for migrating from one version to another one, or from one tech stack to another one. Perhaps it's even a bit cleaner than ng upgrade, because with module federation, you have clear separations. You have your old part and your new part. With ng upgrade, you can intermingle everything, which is both great and bad at the same time. It is great because sometimes we need it. If the domains are intermingled, we need it. But it is bad because intermingling adds complexity. If you don't need this, if you can vertically cut your application, then I would really give micro frontends and especially module federation a try. The thing is, as you are mixing and matching different frameworks here, I would combine both. I would combine module federation with web components, because web components are abstracting the framework away, and module federation allows you to share libraries. Let me show you a tiny blog article about this. I will also copy it into the chat.
When you say web components, do you mean Angular elements?
Yeah,
Okay.
for instance.
Thank you.
And when it comes to AngularJS, you need to wrap your AngularJS code by hand within a web component. Here I have a blog article. I'm getting this question quite frequently, and some of my customers also do this. And here I'm mixing and matching different Angular versions, Angular X, Angular Y, and also React. And because of going with web components, I can abstract the frameworks away. So this side does not even know that we are using another framework on the other side. And because of using module federation, I can nicely load everything on demand. And I can say, well, the shell and the Microfrontend 1 shall share Angular in version X, Microfrontend 2 and 3 shall share Angular Y, and Microfrontend 4, and let's assume Microfrontend 5 shall share React in this or that version. So it does not come without some difficulties. That's why I'm calling it the good, the bad, and the ugly. To make all this work seamlessly together, you need some workarounds. For instance, if you assume that now you have to mix and match different routers, your AngularJS router and your Angular router, they don't know much about each other. So you need some tricks to make them work together in the same browser window, but it's doable.
Excellent. I think next is, go ahead. Next is probably Tobias. I'm kind of happy that you guys are actually using raise hand. It's kind of convenient.
Thank you.
So we are not jumping over each other.
So Manfred, I have a question. When you do federation, what I would envision is that at runtime, I would love my teams to come up with changes in their applications. And as a shell app owner, I wouldn't know when they go through their, let's say, deployment. How do you go about, let's say, the cacheability of those static resources? Where I normally like to put them on the CDN and like to even put them on the cache API of the service worker. Is there a strategy, or is this like something you need to manage yourself?
Yeah, so the first thing is you need to manage it by yourself. And the second thing is you can really put it anywhere or everywhere, because from the browser's perspective, it is just a bunch of static files, JavaScript files. So you can put it also to a CDN. It gets a hash key in the name, and then you just need to tell the shell where the metadata file, the remote entry file, is located.
Okay, so you're saying all these microfrontends will end up as unique chunks. So that's already great. But then when you do that runtime, and at runtime, these chunks will change. So somehow the micro frontend needs to update this kind of central file, right? Saying this micro frontend has now this chunk. Yeah. So is that something this framework supports?
No, there's nothing like this in there. You need to write your own, I'm always calling it registry service, which is telling the shell, well, today I have those micro frontends for you, and you find the versions you are supposed to use under this location.
Fair enough. Yeah, thank you.
Very welcome.
Cool. I have one question. I just raise head for myself, actually. So how it is sharing libraries between different micro frontends? Let's say you have Angular application that could be using jQuery, right? You have another application that is using jQuery. I mean, if we could be using jQuery, do you actually need to load two different libraries of jQuery, or the micro frontend or module federation is actually able to share those libraries together?
Yeah, that's a very important question, because if you ask me, sharing libraries and version conflicts is the most difficult topic when it comes to micro frontends in general. It does not have to do much with module federation. In general, it's difficult to solve, but I can show you what module federation can do for you on this front. Let me just pick for this another slide deck. So this is what I'm doing in my workshops. Yeah. So the fun thing is that module federation has been implemented twice. After it was implemented, after it was in beta, they found out they need to re-implement it to provide more flexibility for dealing and for preventing version conflicts or version mismatches, as they call it. By default now, it has a very smart strategy implemented and activated. By default, it is just selecting the highest compatible version. So let's say that we have the shell and the microfrontend. The shell needs version 10 of something. The microfrontend needs version 10.1 of something. In this case, obviously, according to semantic versioning, 10.1 is the highest compatible version. It is backwards compatible to 10.0. And that's why module federation will choose for 10.1. It will only load 10.1. And this is the very reason why we should load the metadata of all the microfrontends upfront in order to tell module federation about those version numbers. This is the default behavior. Of course, there are situations where there is not a thing like a highest compatible version. Let's say the shell needs version 11 and the microfrontend needs 10.1. According to semantic versioning, those are two non-compatible versions. You can introduce breaking changes with new majors. And in this case, by default, module federation loads both of them, which could be okay-ish. Of course, it is increasing the overall bundle size, the bytes you have to download. But besides this, this might be okay if we are talking about a stateless library. Think about jQuery, think about underscore, think about RxJS. Normally, the one microfrontend
seems like Manfred got version conflict. No, you're okay. Now he's back.
Yeah. Oh, sorry, I had a bad connection, I assume.
Right.
So what was the last thing you heard?
We lost you 5 seconds back.
Okay. Yeah, so as mentioned before, if this is about a stateless library like jQuery, loading two versions of it is not a big deal besides increasing the bundle size, because one microfrontend does not matter if the other microfrontend is using the exact same version of jQuery, for instance. But if we talk here about your leading framework, Angular, this is an issue because Angular is stateful. Angular knows about your components, and now you would have two instances of Angular, besides other issues that are there if using different instances. One instance knows, let's say, 3 components. The other instance is using other 3 components. And they cannot use each other because they live in different Angular worlds, in different Angular containers. If you really need to mix and match different Angular versions, you should hide them behind web components. That means you have to go with Angular elements, or you need to hand wrap them using your own web components. But for libraries, this is fine, even for your component libraries. Of course, there are some other strategies. Those are the default strategies, but there are some other strategies you can configure. Before I'm showing you those, let me give you a more comprehensive example. Let's say the shell is using a library in version 10, Microfrontend 1 is using 10.1, Microfrontend 2 is using version 9, and Microfrontend 3 is using version 9.1. Now, Module Federation would assign version 10.1 to the shell and the Microfrontend because this is the highest compatible version for both of them. And this is only loaded once. And also, as you can imagine, MFE 2 and 3 gets version 9.1 because this is the highest compatible version for them. So at the end of the day, this is about doing a bit of math to determine the highest compatible version. Default behavior. Besides this, you can define that a library is a singleton. That means you go with the Highlander principle. You know the Highlander principle, there can only be one, which means only one version is loaded, which is very likely the highest version. In most circumstances, it's the highest version. So let's say we have 11 and 10.1, then only 11 is loaded and not 10.1. That might work, but no guarantees. You even get a warning at runtime because version 11.1 or version 11 does not need to be backwards compatible to version 10. But you can try it at your own risk. And I think this example shows when you are deciding for microfrontends, you need a good testing coverage in terms of integration tests. Because what you get at the end of the day is you get runtime dependencies instead of compile time dependencies. That means you need to make sure at runtime that everything works together seamlessly. You can also say, hey, let's enforce strict versions. In this case, you don't get a warning here, but an runtime error. Fail fast is here the division. Fail fast, don't do a thing because it might have some bad consequences. Hopefully someone finds out using integration tests. And last but not least, you can also relax the required versions. You could say, well, normally I need version 10, but I know I don't need much of the functionality. It will work fine with everything between version 1 and 11. That's also an option. So as you see, Module Federation gives you a heap of options and you have to choose wisely how to use those options for your libraries. You can even mix and match those options for different libraries.
Pretty cool. I mean, I don't see any questions. I don't see any raised hands. Is there any questions that I missed in the chat? Manfred?
Let me look it up.
Because we have some internal discussion. We have some list of application within SAP, which is great.
At Ariba, this is already working. Okay, cool. That means Ariba, SAP Ariba is already using Module Federation. Did I got this right?
Of course they use.
Nice. Oh yeah, that's your project. Okay, cool, great. Yeah, Dimitri is working on something great on the basis of Module Federation.
Frank, I think we
you
should
guys
probably update the team separately on a separate session as to what we are doing with Module Federation internally as part of SAP Ariba implementation. There is a 1BX project where we are leveraging this. And I think today's talk, Manfred, thank you for enlightening other folks at SAP about this topic as well. But I think this is, in the SAP landscape, this federation becomes not only important, but this is a way for us to move forward in merging various technology stacks at play. I think that is very, very critical. You mentioned about React and mixing and matching that, and mixing. SAP is already on a web component journey as well, how to leverage that. I guess what you're saying is, as long as you can develop the shell as an Angular application, you can stitch together either Angular, the remote application could either be Angular or web components or React from a consumption standpoint. But I guess the need, I think I saw somebody's comment being made, what are the requirements? The requirement is essentially shell needs to be an Angular application. A remote application
it doesn't need to be. It can be almost everything. It also can be a React application or vanilla JS. So it does not really.
Got it. Okay. So I think that is something that we probably need to iron out a bit more details, because SAP's landscape is very, very diverse, where we have a lot of, I want to say, core technologies that SAP has developed. And there are a lot of applications that are getting developed in Angular as well. So how do you mix and match? And Dimitri and team has been helping us develop something called a plugin, which will do this kind of many-to-many mapping. And Frank, I think we should probably schedule a separate session on that. We should probably also invite Manfred and take his input on how we are orchestrating that functionality.
Yeah, I think Dimitri and Manfred were actually syncing as well, right, during the journey, right? Because we were actually using some of the work that Manfred did. He was basically consultant on the side because he was in this module federation for a while, right? So we're actually relying on his skill set as well. And Dima and Manfred actually work together as well, right?
Yeah, we are brothers in arms when it comes to module federation. We are discussing a lot on the Slack channel.
You know, this is kind of actually funny because these GDE guys, Google Developer Expert guys, have its own space, which they can actually chat freely together. They can actually reach out easily to Google folks when something is available. They can actually plan things, and us normal folks, we just need to actually use issues and maybe some emails, right?
But
they have Slack, actually. Right, so cool. I mean, we'll definitely keep you all updated. Thank you so much. And we will actually start planning our next session, our next topics, where what we want to do is that we want to actually, again, bring external speakers. Plus, at this time, we want to combine this with our internal one. So again, thank you so much. Okay, that was my rank, sorry. Thank you so much. And hopefully we'll actually get such a rich attendance also next time. Thank you so much again.
Even more.
Thank you. Thanks, Manfred.
Bye.
Thank you. Thank you, folks. Thanks. See ya.
Thank you.
Thank you, Manfred.
Bye.
Thank you.
Bye-bye.
Hey, little guy.
Bye-bye.
Hello.
Hey, that's girl, but she's really.
Thanks, Frank. Bye.
Oh, sorry.
Thank you, guys.
Thank you,
Very
everybody.
So
nice.
there's actually him who did the module federation, the little guy. Right?
Yeah.
So he was on the side and helping Dima. Cool.
Okay, I also need to go to my family. So it was a pleasure. Thanks, Frank, for having me. And
Thank
see
you, Manfred.
Thank you, Manfred, again. Bye-bye.
Thank you, Manfred. Always glad to see you. Bye.
Always
I
great
can
to see
actually
you.
wait because I have talks on Manfred NG Graz on Thursday, and I'm actually looking forward because he's actually using not Zoom, he's actually using something called StreamYard, which is actually, I'm looking forward actually to see how it actually works, right?
It's really a no-brainer. It is as easy. It is easier than shopping on Amazon.
Yeah, nice. Cool. Thank you, guys.
Hey, Frank, you want to connect
Bye.
separately now? Yeah.
Yes, please.
Okay, thanks.
Continue.
Bye.